So here we are going to talk about the angular momentum. First, I have taken a particle. I will discuss the angular momentum of the particle, and then we will discuss the angular momentum of the rigid body. And then after this, we will also discuss a question from the JEE Mains. So here I have a particle and it is moving with a velocity v. So we can define the linear momentum or the momentum of this particle, right? So linear momentum is mass multiplied by velocity. And now the angular momentum, which is also known as the moment of momentum, is defined like this. L vector for this particle about this origin will be, let's suppose this is r vector, the position vector of the particle from the origin, right? So then the L vector is defined as r vector cross p vector, where r vector is position of particle from origin and p vector is linear momentum. Now we can further write it from this L vector format. We can also write it like this, that it can be written down as r magnitude p magnitude, and let's suppose the angle between the r vector and the p vector is theta, like this I have written down. So then sine theta n cap, where we will calculate the n cap with the help of the right hand thumb rule, and this we will calculate using the right hand thumb rule. Look, sometimes this angular momentum is also called as a pseudo vector. Why? Because we take a particle which is moving in xy plane. So then the angular momentum, like if I take right now this particle, so the angular momentum about this point is r vector is like this, velocity vector is like this. So if I place my right hand fingers on the r vector and rotate it toward the v vector, then I will get a vector which is pointing outside like that, out of the plane. If I take the particle which is moving like this at this point, so then I will get and that vector pointing inside the plane. And now taking the taking a vector outside and the inside, we can take it positive and negative, right? And we can take positive and negative, then we can deal with this if you want to do the sum or anything, any operation on that. So that's why the angular momentum sometimes it is also treated as a pseudo vector, that direction will not play that much role if the particle is moving in a plane. Now this is how we can calculate the angular momentum for a particle. What about how do we calculate angular momentum of the rigid body? So as we know that the rigid body is combination of the particles. There are infinite particles in this rigid body. So then what I can do is I can find out the angular momentum of a ith particle which is at a distance of ri, and I can write down that the angular momentum of this ith particle is ri cross pi. I am just writing down the magnitude. So pi can be written down as m multiplied by vi, and vi, as we know that if it is rotating about this axis of rotation with omega angular velocity, so vi and omega relation is that v equals to omega r. So if we place that value, so li becomes ri multiplied by m, and vi becomes omega ri. So li becomes m times of ri square multiplied by omega. Now if we want to find out the total angular momentum, the total angular momentum will be summation of this total angular momentum of all these ith particles, and which will be summation of mi is the mass of this ith particle, and ri square multiplied by omega. And as we know, this is the expression for the moment of inertia. So the angular momentum for the rigid body, we can write it like this, that L is I multiplied by omega. In the vector format, if we wish to write down, we can write it like this, L equals to I omega. Using this, I can find out the angular momentum of the rigid body. Right now I'm just discussing about the angular momentum of the rigid body which is performing the pure rotational motion. If it is performing the rotational plus the translational motion, which is called as combined rotational and translational motion, or the CRTM, in that case we need to find out one by one this angular momentum for the rigid body about its axis of rotation, plus considering this body as a point mass, and then calculating the angular momentum because of the translational motion. So let us understand in that case how we will find out the angular momentum. So here let's suppose I have a disk like this and it is performing the pure rolling on this surface, or let's suppose CRTM, with a linear velocity v in horizontal direction and with a angular velocity omega like that. So first I can say that it is performing the, if I want to consider this motion, I can consider this motion as the combination of the rotational plus the translational motion. So it is, I can consider it like that it is rotating about this axis with omega, plus it is translating with a velocity v. The one more thing about this angular momentum is, if I look here, angular momentum is r vector cross p vector, so it is also dependent on the origin, where you are taking the origin. So let's suppose I'm taking the origin here, this is the p point. About this p point I want to find out the angular momentum of this CRTM, right, which can be considered like this. So for this pure rotational about this axis, I can say that the angular momentum because of the rotation, let's call it as LR, is, it is performing the rotational motion about this center of mass, so ICM multiplied by omega. Then its center of mass is also translating with certain velocity. So let's suppose the center of mass position vector is r vector, so I can say because of the translation there is a angular momentum, and using this formula, because in case of translation I can consider the complete rigid body as a particle or as a point mass on its center of mass, so then I can use this formula for the calculation of angular momentum. So angular momentum becomes r vector cross p vector. So r vector cross p vector can be written down as mass multiplied by velocity of the center of mass. So the total angular momentum of a rigid body which is performing the combined rotational and the translation motion can be written down as m RCM, position vector of the center of mass, cross VCM plus I omega. So this is the formula for the calculation of our angular momentum in case when the rigid body is performing the CRTM, which is also known as the rolling motion. Alright, so now here I have this JEE Mains question. So a particle is of mass 2 kg is moving such a way that at time t its position is given, and angular momentum of the particle at t equals to 2 seconds, about its origin we need to find out. So there is a particle and we need to find out the angular momentum. So I can use this formula r vector cross p vector, or otherwise I can say that the formula is m r vector cross v vector. Alright, like whenever you get the JEE Mains question, generally the questions will be very simple, and the process would be that you need to think, you need to link what is being asked and what is given. So here I have been given the position and I need to find out the angular momentum, so I know this is the relation, and now I need to figure out what is the velocity at t equals to 2 seconds. So we know that the rate of the change of the position is velocity vector. So v vector can be written down as dr vector by dt. So if I differentiate this with respect to time, so d by dt of 5 I cap minus 2t square j cap. So velocity vector will become 5 I cap differentiation becomes 0 minus 4t j cap. So this is the velocity. Velocity at t equals to 2 second will become, if I just put t equals to 2 seconds, so that is minus 8ij meters per second. The position vector can be written down. Position vector is 5 I cap minus 2t square j cap. So if I put at t equals to 2 second, so t equals to 2 second, position vector will become 5I minus 8j. Okay. So if you substitute here, so angular momentum is going to be 2. R vector is given as, we have calculated 5I minus 8j, and the velocity vector is minus 8j. So we need to do the cross product. We know that the j cross j becomes 0. So L vector will become 2 and I cross j will become k. So 5 multiplied by a minus 8. I am doing this cross product, and this I cross j becomes k cap. So L vector becomes minus 16 multiplied by 5 k cap. So L vector becomes minus 80 k cap, and unit of the angular momentum is going to be kilogram meter square per second. So this is our angular momentum.